Yeah. Students, I'm audible to you. I'm audible to all of you. So welcome to the session, students. Please tell Meenakshi, Meghna, Ramakrishna, am I audible? Yes. Yeah, that's good. So, students, we are going to talk about fluids. So, fluid mechanics basically, you can categorize fluid mechanics into two parts. One is static part. One is static part. When the fluid is at rest. And the other part is dynamic part. Okay? So when the fluid is moving, right? So students, in static part, basically, we study about, Archimedes principle. Static means rest, and dynamic means in motion, right? Who's there? Rohit, right? So, in static part of fluid mechanics, we study about Archimedes principle. Okay. So, students, do you have any idea about this principle, Archimedes principle? Any idea of that? You can respond here. Any idea about Archimedes principle? Yes? Okay. So if you have an idea, yeah, buoyancy. Right. No problem. I'll explain that. And in dynamic part, basically, we have equation of continuity and we have Bernoulli's equation. Okay. So first of all, let me tell you about Archimedes principle. Yes, very good. Who's there? Yes, Shreyas, absolutely right. You are saying that upward force is equal to the weight of liquid displaced. So, dear students, if you suppose there is a container, let's take it in black color. Yeah. Suppose there's a container, and the container contains a fluid, say a liquid. Okay. So let's say it contains a fluid. So if something is submerged in that, if an object is submerged, yeah, when the object is submerged, it displaces certain fluid, right? When the object is submerged inside, it displaces fluid. And the displacement of fluid, you can say the fluid displaced has same volume as the volume of the submerged part, right? So basically, we know that the upward force or upthrust, net upward force by a liquid, net upward force by a liquid is equal to weight of liquid displaced, right? So let's see a question, and a question will clarify the things more, right? So in the given question, we are provided that a homogeneous solid cylinder, right? Homogeneous solid cylinder of length capital L and cross-sectional area A by 5 is immersed such that it floats with its axis vertical at the liquid-liquid interface. So it's given that this length is L by 4. It's L by 4. So complete length is capital L. So you can say that this length is equal to 3L by 4, right? You can say this thing, it's 3L by 4, right? So now, if it's given that the upper liquid has having density small d and the lower liquid is having density 2d. Okay? So what we have to find, we have to find the density of solid. Okay, density of the solid cylinder we have to find. Okay, so now how to solve this question? Now this solid cylinder is placed inside the liquid and it's immersed, and you can see that it's in equilibrium. So as it is in equilibrium, that means the net upward force by liquid, or you can say the upthrust of liquid, is balancing the weight of the liquid, right? So if you consider the upper part, how much part is immersed, students? How much volume is immersed? You see 3L by 4 is the length and the area of cross section is A by 5. So how much volume is there that is submerged? You can easily understand that in upper liquid, volume submerged is equal to 3L by 4 multiplied by A by 5. So this is the volume submerged. And you can also understand that this is equal to the volume of liquid displaced, right? This is equal to the volume of the liquid displaced. So what is the buoyant force? What is the buoyant force applied by the upper liquid? So buoyant force is equal to weight of liquid displaced. Okay, so weight of liquid displaced we have to find. Shubham, which thing you can't understand? Just see this thing here in the upper liquid. 3L by 4 length is there and A by 4 is the area of cross section. It's given in the question, right? So the volume of the substance, sorry, you can say the volume of cylinder submerged is equal to length into area of cross section. Length into area of cross section, right? So that's what I have written here. So, and that volume submerged is equal to volume of liquid displaced. This is equal to volume of liquid displaced, right? So now buoyant force is equal to weight of the liquid displaced. Now what do you mean by weight? Weight means mass into G. So how to find the mass? You can understand that density into volume of liquid displaced multiplied by small g. This is the buoyant force, right? What you're saying, will the liquid in the upper section apply force in the upward direction? Or better see, Shreyas, actually you should understand that the net force, it will be in upward direction. The liquid may apply downward force, that's not a problem, but the net force will be upwards. Be clear about this thing. Net force will be upwards. Okay, so density into volume into small g is the buoyant force by the upper liquid. So the density is how much? It's small d. And the volume is how much? It's given as 3L by 4 into A by 5 multiplied by small g. Net force, net buoyant force, Swapnil. Net force in upward direction, you can say the upthrust is equal to weight of liquid displaced, right? So that's buoyant force by the upper liquid. Similarly, buoyant force by lower liquid, So you can understand that how much volume is displaced by the lower part. See, L by 4 is the length, and again A by 5 is the area of cross section, and volume, length into area of cross section. So for the lower part, for lower liquid, you can see for lower liquid, volume of liquid displaced is equal to L by 4 into A by 5, right? So buoyant force is equal to, now what's the density of that? Density is given as 2D. So 2D is the density. So buoyant force is equal to 2D multiplied by L by 4 into A by 5 into small g. This is the buoyant force by the lower liquid. So these two buoyant forces actually are balancing the weight of the solid cylinder, right? So we can write here that what is students, what is the weight of the cylinder? You can understand it's equal to m into g. So if density of this solid cylinder is capital D, we can say mass is equal to density multiplied by volume. And what is the volume of that? It's given that this area of cross section is A by 5 and this length is capital L. So D multiplied by A by 5 into capital L. So this is the mass. So what is weight? Weight, you can understand that it's equal to m into g. So you can say it's LA by 5, or just simply write it same like that. So D into A by 5 into L multiplied by small g. That is the weight. So now you can understand from the problem that the cylinder is in equilibrium. Equilibrium means that the net force on the cylinder is 0. So that means the buoyant force in upward direction is balancing the weight. So simply you can say, let's equate these two, this weight and the net buoyant force by two liquids. So D into A by 5 into capital L into small g. That's the weight, and the buoyant force that we have calculated. Students, just it's a request to all of you. If you don't understand, please hear recording later on. Okay, I've explained each and every step very elaborately. Okay, so this is the buoyant force by the upper liquid. So simply write it there. So you can say it's equal to 3L by 4 into A by 5 into small d into small g, plus for the other liquid, it's equal to 2D into L by 4 into A by 5 into small g. So you can say L by 4 into A by 5 into 2D into small g. So from these equation, you can understand that A by 5 can be cancelled from both sides, and G can also be cancelled out from both sides, and also L can be cancelled out. So in the end, what you got? You get D is equal to 3 by 4 into D plus D by 2. And that implies capital D is equal to 5 small d by 4. So that is the final answer, right? So which one was correct? So B, sorry, A was correct option. Now let's see the second question. Now this question will clarify your doubts regarding this concept, right? Okay. So now see in this situation, what is given? A hemispherical portion of radius capital R is removed from the bottom of a cylinder of radius capital R. So what is given here? There's a cylinder, and the cylinder is having radius capital R, and one part is removed. Okay, one part is removed. Let's say this part is removed. As you can see in the figure, so the volume of remaining cylinder is capital V, okay, and the mass is capital M. So we are talking about after removing the you can say the hemispherical part. So the volume is capital V and the mass is capital M. So it is suspended by a string in a liquid of density rho, where it stays vertical. The upper surface of the cylinder is at a depth of h below the liquid surface. The force on the bottom of the cylinder by liquid is. The students, you should understand one point, and the point is that what is buoyant force? You might think that like this cylinder is submerged, so the upper part must be applying some force over it, right? The upper part, you can say the upper liquid must be applying some force on that, right? So that's right. So I told you that buoyant force is a net force applied by liquid in the upward direction. So let us say that let us consider this free body diagram. Let me draw it. This is the object, and the lower portion is kind of removed like this, and it seems like this. So now let's say this is upward force applied by liquid. This is downward force applied by liquid, and this is the upward force. So you should be clear about this thing, that buoyant force that we calculate is equal to Fu minus Fd. That is equal to buoyant force, right? That's equal to buoyant force. So buoyant force, what is the value of buoyant force? The buoyant force is equal to weight of liquid displaced, and you should be clear about this thing, that volume of the cylinder remaining part is V. So this much amount of liquid is displaced, right? So this much amount of liquid is displaced here. So V multiplied by rho of cylinder into small g, this is the value of buoyant force, right? This is the value of buoyant force. Now, if you talk about the downward force, so students, you should understand that the pressure difference between 2 points having height difference of small h is equal to rho gh. If height is small h, so the difference of pressure between these 2 points is rho gh, right? Rho gh is the pressure difference. So here you see that this part of solid cylinder is submerged by h height. So amount of water is up to height h. So you can say that the upward force is equal, the downward force is equal to rho gh multiplied by area of cross section. Now in the question, it is given that capital R is a radius. So rho gh multiplied by pi capital R square, this is a downward force, right? So buoyant force is equal to Fu minus Fd. So we have to find the force applied at the bottom in upward direction. So say Fu minus of rho gh multiplied by pi r square is equal to V rho into G. So from here you can understand that Fu is equal to, let me write it here. So you can understand that Fu is equal to V rho G plus rho Gh into pi r square. Okay. So you can see option D is the one that we have to choose here. So let's move on the third question. And this question is based on dynamic part of fluids. So what's given in the question? And the question is given that a spray gun is shown in the figure. A spray gun is shown in the figure where a piston pushes air out of a nozzle. So this one, you can see this is a spray gun and this is nozzle. Okay. So your nozzle. So a thin tube of uniform cross section is connected to nozzle. The other end of the tube is in a small liquid container. So you can see that there is a small tube connected with this nozzle and one part of it is submerged in a liquid, right? So as a piston pushes air through the nozzle, the liquid from the container rises into the nozzle. Okay. So radius of the piston and the nozzle are given as 20 millimeter and 1 millimeter respectively. The upper end and of the container is open to the atmosphere. So that's the comprehension. Now let's see what the question is. The question says that if the piston is pushed at a speed of 5 millimeter per second, the air comes out of the nozzle with a speed of. So in this question, what we are required? In this question, we shall apply equation of continuity. And you should know that if there is a pipe of varying cross section, so if let's say this area of cross section is A1 and V1 is the speed of liquid here, and if you talk about this cross section having area A2, and if you want to calculate the speed of liquid here, so you should be clear about that V1 A1 should be equal to V2 A2. That is the equation of continuity, right? So in this given question, we have to find the velocity of the air at the nozzle. So if the piston is pushed with a speed of 5 millimeter per second, 5 millimeter per second. So now what is there inside the tube? Okay, what is there inside the tube? Inside the tube there is air. Okay, inside this tube there is air. I'm saying that, I'm repeating the same thing again. You should be clear that inside this one, this tube that I'm pointing here, there's air. So if you push the piston with the speed of 5 millimeter per second, the air will also move with the same speed, 5 millimeter per second. So with how much speed it will come out of the nozzle? So simply apply this principle, V1 A1 is equal to V2 A2. So now what is A1? What is the area of cross section? What is the area of cross section here? Given that 20 millimeter is a diameter here, so area will be A1, let's say, is equal to pi into 20 square. And talking about this one, area is equal to pi, area is equal to pi into 1 square, right? So A1 is equal to pi into 20 square and A2 is equal to pi into 1 square. So students, you should understand that we have found the areas and now we have to find the velocity. So velocity v1 is given as 5 millimeter per second. Just substitute the values, you'll get the answer. That's very easy, right? So pi into 20 square multiplied by 5 is equal to v2 multiplied by pi into 1 square. So from here, you'll get the answer that v2 is equal to 2000 millimeter per second, and that means v2 is equal to 2 meter per second. So that's the answer. So Ayush, you can see the recording later on. Okay. So C is the correct answer. Yes, Meenakshi, you're absolutely right. Now let's move to the other part of the question. Now this question, this question says that if the density of air is rho A and that of liquid is rho L, then for a given piston speed, the rate, or you can say volume per unit time at which the liquid is sprayed, will be proportional to. So what we have to find, we have to find that the velocity with which water comes out, we have to find that speed, or basically we have to find in which part it's directly proportional. So students, here we are going to apply Bernoulli's theorem. And Bernoulli's theorem says that P, pressure, half rho V square plus rho GH is a constant value. So basically, Bernoulli's theorem is actually, you can say, is the restatement of conservation of energy. Okay. Conservation of energy. So that's what we have to apply here. So students, please stay focused in this question. This question requires a lot of focus from your side. Okay. Now, just hear properly what I'm saying. Now, see, air is at rest here. Yes, air is at rest here. So the pressure will be equal to P naught here, right? Now, at this point, just above, at this point I'm talking about just above this, you can say tube. So here, the pressure will be how much? It will be equal to P naught minus half rho V square. Let us see. Students, just see this thing. Right now, I'm just telling you the basic formula, or you can say the theorem, that P plus half rho V square plus rho GH is a constant value. Okay. So, and that's valid for the liquid that's incompressible, right? So P, the pressure, and rho is the density of fluid, V is the velocity, and you can see H is the height from the reference level. Okay, so the sum of these three remain constant. Okay, so here, what is given? In this question, we have to find the velocity of liquid by which it comes out. Okay, so now see, these 2 points that I'm pointing here, these 2 points, let's say this point and this point. Okay, let's say this point, let's say this point A, this is point B. They're kind of, they're at same height, Just apply this principle. Now liquid at rest here, So P naught plus half rho into rho air into 0 square. Okay, 0 because air is at rest here, and let's say rho GH. Let's say rho GH is a potential part of that. And for point B, this is for point A, and for point B, it's equal to P naught. Let's say it's P. Don't know the pressure here. So half rho V square. We are clear about that. VA is the speed of air. at here at point B. Okay. See, Meenakshi, we're talking about reference level. You take height from reference level. Reference level. Okay. So half rho VA square plus rho GH. Now both of them are at same height, so you can cancel out this part, and this becomes 0. So you can say that P is equal to P at point B is equal to P naught minus half rho B A square, right? So what I'm saying that I'm saying pressure at point B is equal to P naught minus half rho A VA square, right? And that is the pressure due to air at point B. Now let's talk about the fluid. We can see the liquid. So as you can see, this is open. This is open. The fluid, the container is open. So what's the pressure here? Pressure will be P naught, right? It will be P naught here. And you see at the lower part, let's say this height is H1. Let me redraw it. Let me redraw it. So this is the container, and this is your tube, okay? And this one was the upper nozzle, okay? Now, this was point B. This was point B, at which we have found the pressure. So now let us say that the liquid is having height H1. So here, let's say pressure is P naught, atmospheric pressure, because it's open. It's open to atmosphere. So if you just talk about pressure here, you can say it will be P naught minus rho G H1. And now you should understand that liquid is moving in upward direction inside the tube, right? So let's say the speed of liquid be VL. So just inside the tube, the pressure will be how much? P naught, sorry, it should be plus, not minus. Okay, P naught plus rho G H1 minus half rho rho liquid and V liquid square. Okay, so that's what the pressure is at point, let's say at point C. Okay, let's say this point is C. We have to find the speed with which liquid comes out. Okay, with which liquid comes out. So basically, if you talk about pressure due to this liquid around this point B, it will be same as PB. Right, I'll equate that. Now let us say that liquid is at height small h, H2. Okay, let us say its height is small h2. So you can see that pressure due to liquid at point B will be how much? It will be how much? It will be equal to P naught plus rho G H1 minus half rho L BL square minus rho G H2. Okay. So this is a pressure at point B due to liquid. Okay. This is a pressure due to liquid. So now equate these two equation, because pressure due to liquid and due to this air will be same. Just equate them. P naught plus rho G H1 minus half rho L VL square minus rho G H2 is equal to how much? How much it's given? It's equal to P naught minus half rho A VA square. So P naught and P naught can be cancelled. So students, from here you can see that that rho L VL square is equal to rho A VA square and minus, minus, or you can say plus rho G H1 minus H2. So simply, you should say that velocity of liquid is equal to under root of rho A VA square divided by rho liquid plus rho G into H1 minus H2. So in the given question, we were asked that velocity of liquid is proportional to what thing? What expression? So you can see rho A under root rho A by rho L is coming in this expression, right? So we can see VL is proportional to under root of rho A by rho L. So that's what was the correct answer. So that's why the correct option is A. So students, thank you so much. Thank you so much for being there, for attending the session. I hope you loved it. So for more information, you can subscribe or you can click on the given link. So thank you very much. See you. Bye-bye. All the best.